class, our objective is to demonstrate how the RK4 algorithm is used. Basically, some of the calculation I have already done. I will just demonstrate it. I am also taking this old picture as you have seen earlier. The same diagram is also there. The equations also I have taken. Equations is actually simple. You need not memorize all of them. So first thing first. So we already know mu max and x0, these are the constant from my equation. This is the time scale t0, 0.1, 0.2, like this increasing. So first thing we have done is that we are calculating the h is actually from first point to next point, what is the time gap. So 0.1 means everywhere the point is 0.1, 0.1. I can just do the subtraction. I'm doing a4 minus a5. I'm drawing the h part because in most of the equation also we are having h, so better to draw. Now I will do some sequence that I will need to tell you. So first thing is initial x. So initial t I know, initial x, that means this point, a point. Initial time I know, initial x, and slope at point 1 is k1. So k1, that I will do calculation. Then this e point, d point is this point we have already told. So using this slope we will reach point d. So d point also, d point has two things. One is what is the x value of this, what is the y value of this, and what is the slope calculated at this point. So this also has a t, x means time, x-axis, y values, that is x here biomass, and slope calculated at this point k2. Similarly, we will have another point that is called e point. So for e point also time, x, slope at this point, and finally using this slope we are going to reach point f. So this point is f actually. So t, x, and finally k4 values, and then last column will be average calculation. So anyway, I'll show you how we are going to do. So at first point, time 0, x is, I already know, initial x is given. What is the slope at this point? That is simply function of xn, yn. What is xn? Xn is, in my case, x is time, so time is 0, and y means in my case that is the biomass concentration we are going to calculate. So we can do it very easily, and slope is mu into biomass. So essentially I know the mu value or k1 value, the slope value is mu x, because dx dt is mu x. So slope is mu into, you can see, mu into corresponding x. So that is the first slope. So slope, this k1 value I calculated, k1. So that is very simple. The first thing we are showing here, k1 is calculated. If k1 is calculated, what will be our next part? Our next part will be, okay, using k1, that slope, we want to go to midpoint. So first thing is, what is the coordinate? So this point coordinate, you know, it will be xn plus h by 2. So I will discuss. And what will be the this point y-axis value? That is, already I am having whatever y I already have, plus k1 into this h by 2, that is the extra height we are gaining. So we can easily calculate the coordinate of d point. So what is the time? So what is the t-axis? Means x values here, that is whatever you already have, that is a4 times 0 plus 0.5 into h, you see, h by 2. So we are writing a4 plus 0.5 into h. H is already known, 0.1. So d point x value I got, x means x-axis, and what is the y value here? Simple. So y value is whatever original biomass concentration we had, this one, plus k1 slope, but I will go only h by 2 distance. So e4, that is the original x value here, plus h by 2, h is d4 by 2 into f4. F4 means slope k1. So using slope k1 I am reaching this point. That is actually this part. Xn plus h by 2 is the x-axis, yn plus h by 2 into k1. So I reached x and t and x value. I reached this point d. If I reached d, calculation of k2 is very simple. It is mu into x. That means essentially mu into current x, new x. So I can calculate k2 value. So reaching here I can calculate k2 very easily. Now using this k2 I have to start once again. I will use the same k2 and I will come half of the distance to point E. So this aspect is required. So k2 calculation was very straightforward because based on this value only, this position, d position, this is d position. D position I have just put the function, so I got k2. So up to this point we have already discussed. Now once I know k2, I have to reach point E, that I am writing it here, that is xn plus h by 2, because x-axis coordinate is same for d and E also, but here height of this point E is yn plus h by 2 into k2, because it is based on now k2 slope. So what we are doing, time is same, that is original t0 plus half of this, and x value is whatever we had original x plus h by 2, but this time I will use k2 slope. So j4 is k2 slope. So I reach the point E and I know its coordinate, xy coordinate. Calculating slope at k3 is very simple, same way, mu into x, you see, same way you are calculating k3. So k3 calculation is at this point. I am calculating k3. K3 calculation is done. Now using the same slope as k3, I will go full distance. Now our time is not half h, it is just whatever time we had plus h. So that is a4 plus d4 we added, we got the new time. And what is my y value? Y value will be calculated based on whatever k3 we had multiplied full distance is h. So we can see our new x value is original x plus h full length and k3 values. So I will reach this particular point, that is called f. F point we are reaching, it is not E, it is actually f. So we are reaching f point, that means here, and f point I will calculate simply what is the slope. That calculation is straightforward. So I know the point, slope is function of that particular point coordinate, nothing new here. So I can calculate slope at point f. Done. So I got k1, k2, k3, k4, and then average k. Average k is k1 plus 2k2 plus 2k3 plus k4 by 6. So I got the average slope. So if I know the average slope, so what will be the new point? New point is very straightforward, because I know my time change was 0.1 from earlier point to this point, the gap is h, and that is the slope. So k into h is the increment, what was our old x, so old x plus average slope into h is giving me my new x values. K also can be simply done because the same formula is there, so we need not do same logic, because now 0.2 into corresponding value of E4 is coming over here, because slope is for this point, for example, it is coming for E5, so corresponding x. So I think I need not do all those calculations once it has been done, and the all other calculation can be simply dragged, because now same approach will be done for all those points. You can just verify for few points, you see doing correctly. Time is done correctly because 0.1 it has already reached, So we are doing similarly at this point. What is the calculation of x for point D, new point D? So I have reached there, then I am repeating this k3, all those things simply I can drag. Once I calculate this new x, then other things I can simply drag. So now I will remove them because I will do the dragging part. These are no more required. So I hope you understood all those derivation aspect of this Rangekut algorithm. We can delete them. We already for derivation it was required. So if I delete, then my job is simplified, and what I will do is that after this point, because this point is done, we have the formula written everywhere. We have a formula, one line complete. Then we can drag it. I think you can see it is doing correctly. New point is calculated both based on old point. This is a new time frame for its own calculation. So this is simple enough. So I'll just drag it further, whatever time point we need to solve. For example, we have done it. So this is our solution for Rangekutta based method, where my time value is this one, and my x value for this case we are getting. So this is my solution, and I will show you how it will be. So this is the solution we are getting for using Rangekutta methods. And if you see what was the original solutions for Euler's method, it will be very close. For example, after 10 we are getting 36.95. In case of 36.95, you see, when we are solving using the mathematical approach, we know the equations. Rather, I will say not a numerical approach. We already know the calculus we are solving. Then also you see after 10 minutes the value is 36.95, and RK4 is also we are getting 36.95. That means they are very perfectly matching with Euler's method. But when we have done it for maybe I'm sorry, RK4 algorithm, when you have done it for Euler's method, you see it was 36.22. Some deviation was there, but this part is perfectly matching, near perfect matching. Error is negligible one. So this approach we are going to get the solution vector for RK4 algorithm. I hope you understand.